Get a little recording for today. And if we're given an equation, convert from Cartesian to polar or vice versa. If we want to, let's say we had our 2 cosine theta. And we plotted this on Friday. It was just a circle over here on the right. So it wasn't centered about the origin. It was just shifted. Still a radius 2. And we should be able to like write down, even if we were just given that circle, what is the Cartesian equations? We should have an intuition for what that should be. So how do we get that analytically from our polar coordinates? Well, we just use our equations and substitute everything in. So R's always going to be an easy one. It's always just square root of x squared plus y squared. What do we do with the cosine? Well, we want to solve it for x. Unfortunately, there's an r there. So our cosine of theta, if we were to solve for it, is x over r. So we kind of made a little bit of progress there. We got rid of the cosine of theta, but we still got an r there, which we need to then substitute with another square root. So that's the way you get rid of sines and cosines in general. As long as the argument is only a theta, sines and cosines, we can essentially just solve our x and y equations for sine and cosine. And then you can replace that r with square root of x squared plus y squared. So if you want to keep track of those and keep them as equations of themselves separately, feel free. Of course, these you shouldn't have to memorize. You can always solve them from these. These 5, I would definitely recommend memorizing, or at least having a strong intuition of where they come from so that you don't really have to memorize them. You can kind of just draw a picture and figure them out. So sines and cosines are pretty easy to substitute out now. And then what we want to do is just maybe play around with this. I mean, this is a good equation. It's a Cartesian equation, but it doesn't look like a circle equation, right? So this is one of those things that again, especially on a multiple choice exam, where this isn't a bad equation. It's just maybe not an answer that's listed. We want to put it in the nicest form as we can. Of course, when I multiply my square root of x squared plus y squared over, that's our first algebraic step, it'll get rid of the square. A better equation with that guy, but still not quite what we like in terms of a circle equation. So how do we develop a circle equation? We need to complete the square. So remember how to complete the square. We only need to complete the square in terms of x. My y is already y minus 0 squared. So my x has this linear term. So I take the linear coefficient, 2. We divide by 2. And then we square it. Nicely enough, in this one, we've got easy numbers. And so we get a +1 there. And since I added 1 on the left side, let's go ahead and add 1 to the right. And then now this guy looks like I messed up this minus sign. This should be a -2 when I subtract that 2x over. This guy will be quantity x minus 1 squared plus y squared equals 1. And that is a nice Cartesian equation. We see where's the center of the circle. It's going to be at 1, 0. And of course, the radius of the circle is 1. This is our typical x minus k, y minus h equals r squared is our standard format for circles. And we can play this game with essentially any equation and go back and forth. The ones you want to be careful about, and it looks like there is one. Actually, I don't know if there's one like a cosine to the sixth on the homework. I don't think you have to actually convert that to rectilinear coordinates, but it's going to change. Like if I have r is equal to sine of 2 theta, be careful because we can't replace sine of 2 theta directly with x's and y's like we did with these last equations. It's only theta. X is r cosine theta and r sine theta. So we have to deal with this. Anytime we have a multiple angle or a coefficient in there in the angle, we've got to use our good old double angle formulas or our angle addition laws for sine and cosine functions. So you got to think way back to pre-calc, and probably don't remember those, so feel free to look those up, especially for the homeworks. I'm not sure if we'll give them to you on a midterm or a final. I feel like we would. I mean, we gave you guys one on the last quiz. I don't know how much formulas we would expect you guys to memorize, and I think even in pre-calc, we would give you guys the angle sum and addition formulas, the double angle, half angle formulas. So I think if you really need to use them on a quiz or a midterm, we'll give them to you. So we'll go ahead and convert this. We've got r squared of x squared plus y squared. Our sine of 2 theta, you look up the double angle formula for that, and it's going to be 2 sine of theta cosine of theta. And so by reducing the angle using a double angle formula, now I've got sines and cosines. Then we can now use those equations we came up with. So we had 2. Sine is going to be y over square root of x squared plus y squared. And cosine was x over square root of x squared plus y squared. So solving it out, the right side is just going to be 2xy in the numerator. The square roots are going to go away, so we'll have x squared plus y squared in the denominator. And then how do we simplify this? About the simplest, I guess we could get it, is to multiply the x squared plus y squared over. And this will be x squared plus y squared to the 1 times x squared plus y squared to the 1/2. So it'll look something like x squared plus y squared to the 3/2 equals 2xy. Probably about the easiest we can get these. And a lot of these that we've kind of been graphing in polar coordinates, they get even more complicated. So we did one on Friday. What was it? R is equal to 1 plus sine theta. Leave you guys to try that on your own. Of course, what's going to happen, we'll have a square root of x squared plus y squared equals 1 plus sine is now y over x squared plus y squared under a square root. And that's where things get a little messy, because how do we simplify that? I could multiply x squared, square root of x squared plus y squared, but don't forget that 1, because I would have to multiply it to both sides. And so that square root of x squared plus y squared will distribute. It'll cancel that one. And then, of course, multiplying that on the left, at least the square roots will go away, but then I still have a square root term there. And it's where it gets a little hairy, especially with some of these, is how simplified is simplified. So I would say, especially on a multiple choice, hopefully the equations aren't too complicated. And then on homeworks and stuff, written homeworks especially, as long as you get the base equations, and if it's not like a circle or something that's immediately easy to simplify, as long as you get a good equation, it'll have to be good enough. Let's do one more. So let's go the other way. Let's say if I have a Cartesian equations, how do I convert that to polar? Those are a little more straightforward. just because in Cartesian equations, we have direct substitutions. X equals r cosine theta, y equals r sine theta. We don't have to kind of maybe finagle these like sine and cosine formulas to get easier substitutions. So even like, let's see, let's do a straight line. Y equals 3x plus 2. If we want to convert that to polar, well, y is r sine theta, x is r cosine theta. And that's a good equation. Ideally, if we can, we maybe want to try to solve for r and write r as a function of theta. So how do we solve for r? Put all the r's on one side. Factor. And then solve. So you can check those ones on Desmos, but that's going to be pretty typical. This process, I mean, if it's a quadratic equation, any other equations, use your r sines and cosines, and then sometimes there's some simplification to do. Of course, you may want to use Pythagorean identities, right? If we were given the equation of a circle, x squared plus y squared equals 4. We would have r squared cosine theta squared, r squared sine theta squared. And then, of course, I can factor out the r squared to get cosine squared plus sine squared equals 1. And you get something like r equals 2. Let's see. Any other ones that you might need to simplify? I think we've seen that lines through the origin should be given as just theta equals a constant. So if we have r sine theta is 3r cosine theta. Well, this is where we kind of finagle our math a little bit. If r is constant, or if r is non-zero, we, in some sense, want to think I can just divide out the r's in that case. And then we get divide by our cosine. We'll get sine over cosine, so tangent of theta equals 3. Or in other words, theta is equal to arctan of 3, which would give us that angle. If we're going through the origin, we're rising 3 for every 1. And of course, typically how we would solve for that angle is arctan of 3. Any questions on any of that? Okay, so let's get some breakout groups